Alright, let's look at the homework 9, problem number 7. Let's do just part A. Alright, so part A say that, find the dimension of the rectangular box with square ends that satisfies the delivery services restriction, which is the length plus girth cannot exceed 24 inches. And we want to find the maximum volume. Alright, so let's do that. Alright, so let's draw a picture. So we have a box, it has a square end. So let's call this guy x by x, right? Then the length is L, so it's gonna look kind of like this. Alright, so this length is L there. Right, so the requirement is, girth would be x plus x plus x plus x, so it's going to be 4x. And the length is L. And cannot exceed 24 inches. So since we're looking for the maximum volume, so why don't we set that equal to 24? Right, 24. Right, let's see. Alright, so from here, I'm going to actually solve for L. So I'm going to subtract the 4x. So we get that L is equal to 24 minus 4x. Alright, actually, both has 4 in it, so I'm going to pull out 4. And it's 6 minus x, right? Alright, and the volume, so let's call this guy volume V is equal to, volume would be x times L, right? So this is going to be, so we can just plug in 4 times quantity 6 minus x for L. So you have a 4, there's an x squared, and then you have 6 minus x. Alright, we got that, right? Then what we want to do is we want to maximize this function. Alright, so this is going to be a function of x, and we want to maximize this volume here. Alright, so let's do that. So let's find a critical number by taking a derivative. So b prime is equal to, leave 4 alone. Actually, let's see, I'm gonna just go ahead and multiply out. So I'm gonna leave 4 alone, but I'm gonna distribute x squared to 6 and the negative x, so that it's gonna have just 6x squared minus x cubed. Alright, so derivative of that would be 12x minus 3x squared, right? So we can pull out 3x, so it's going to be 12x. Right, it's going to be 4 minus pull out 3x, so it's going to be just x. Right? So this is the derivative, and I'm going to just set that equal to 0 to find critical numbers. Looks like set x equal to 0, so x equals 0 and x equals 4 would be the critical numbers. Alright, let's see where the maximum occurs. Alright, so I'm going to kind of look at the shape of the volume function by observing the derivative. So here we have v prime, and I'm going to put 0 right here, and maybe 4 right there. Alright, so I'm going to just try some number. Let's try something like x equals 1, and after 4, I'm going to try x equals 5. Alright, let's see, if you plug in 1 in the derivative, so this is going to be positive. 4 minus 1 would be positive, so it's positive here. Alright, if you plug in 5, 5 positive, 4 minus 1 negative, so it's going to be negative. Alright, which tells you that the original function, volume function v, is increasing on the interval between 0 and 4, and after 4 it's decreasing, right? So this tells you that we're going to have a maximum at 4. Alright, so when x equals 4, it's going to be a maximum. So I'm going to just find the volume there. So volume at 5. So v of 5 would be. Alright, so volume function is here. Right, so it's going to be a 4 times and 5 squared. Right, and a 6 minus 5. So I'm just going to write that. Right. This is actually kind of nice because 5 squared would be 25 times 4 is 100. 6 minus 5 is 1, so it's going to be just 100. Alright, so let's type it in. Alright, so the dimension of the dimensions of the rectangular box, well actually they want the dimensions, right? So here I have to. Alright, so it's going to be, we found that the x is equal to 4. So it's a 4 by 4 by, alright, I have to find a length. The length here, so L is going to be 4 times 6 minus 4. Oh, actually, I messed up. Sorry about that. I lied because I plugged in 5. I should have plugged in 4 there. All right. So, but you have let's see, it's 8. So it looks like it's a 4 by 4 by 8. Right. So forget about the a v of 5 because I was supposed to find v of 4. All right. So here. So I guess I would write the 4 by, let's see, is there a multiplication sign here? Probably it's somewhere, right? So 4 by 8 would be the dimension. Use comma to separate. Oh, okay, so let's see. We might have to use comma here. So how do I do this? All right, how about this? 4, 4, 8. Is that how they want it? Let's check the answer. All right, we got that. All right. Then we have to find a maximum volume. All right, so maximum volume would be V of 4, not 5. All right, so this is going to be, let's see, 4 times 4 squared, and then you have a 6 minus 4. Alright, so we have a 4 cubed is going to be 64, and times 2, so 128. Right, so the volume is going to be 128. Alright, let's check the answer. Alright, we got that. Alright, that's it. I'm going to do a part B in a separate video.